All right. Some technical difficulties.
In the case we need a student.
No, it's okay. I think it should be okay. So first, before I start recording, I would like to thank you for inviting me, because the first time I was here was 20 years ago. And what I'm going to be talking about is the mistakes I made myself. But over the years, hopefully there was some improvement, and I want to share with you what those improvements are. So as usual, this topic is controversial. So my name is Alex Walensky from the University of South Florida. The right spelling of my last name should be like this in Polish. And one of the reasons is because I looked at the 23andMe data, and I'm quarter Polish, and it specifically identifies me, jak Polak, z województwa mazowieckiego. But this is how my name is spelled in Russian, and I'm pretty sure that this spelling is correct. The title is Polish Papers in Nature, Science, and Acta. And for Acta, I mean any kind of journal that which name starts with Acta. Acta Materialia, Acta Biomaterialia, Acta Physica, and so on and so forth. If there's such a journal, maybe not. So looking at this picture, who do you think is the true scientist here? The last one. Well, I would say all of them are scientists. It's just, the one in the middle has this kind of idea to measure the hardness of the microscope, and the other one is using it as maybe a telephone, and finally gets to this. So I would say the scientist is the one that's using continuous improvement and ultimately gets to the truth. And we will never really reach that part of understanding how this universe works, but we're trying very hard. So I'd like to start by this saying in English: there's more than one way to skin a cat. And I tried to translate this into Polish, and I did not find a translation for this idiom. You can see the meaning, and you understand the meaning, but there are several translations in Russian that I found, which some of them are kind of interesting, and there's still research going on of what this actually means. But my message to you is, let's not kill the cat or the messenger, which is me, but let's have an open discussion to see which way is better and more useful for us. As you know, the Ministry of Science and Higher Education in Poland ranks all the journals in quantized physics numbers. There are points that are assigned to the journals. And from what I understand, scientists at Jagiellonian University are encouraged to publish papers in journals that are 140 points and above. What this literally means is that you are kind of forced to publish in very good journals, and that may be not necessarily encouraging internal collaborations within the department or between other departments. Acta Materialia, which is the top journal in the field of material science, has the top ranking of 200 points, but Philosophical Magazine, which was founded in 1798, and people like Maxwell and Rutherford published papers, and there is only valued at 70 points. I'm not going to emphasize the criticism of your specific system of the points, but you know that very well. So, but this is what I saw in the National Museum here in Krakow. And I want to point your attention that in every hall, there's this kind of sign, which is very interestingly translated in English, and everybody who speaks English is going to read this, and it says to put the folders back on place, and I understand the literal translation because in Russian it would say the same thing, on place, na miesto. But what would be the perfect translation? I would say, please return the pamphlets. A folder is something else. It has a different meaning. A folder is something that folds. But maybe there's no reason to put a sign at all. We're all civilized, and if you want to look at the pamphlet, you can return it. But more importantly is that there was a lot of research done on this piece of artwork, and you can see the credits here, some people from Jagiellonian University and also from Germany. I don't know if you can see, but this is some maybe data for XPS or EDS, and if you look closely, and I think this plot comes from Germany because of the file naming system, but here you can see KA and KB, and you probably know what that means, right? What does that mean?
Spectrum.
From what? Ref spectrum from what? Ka and Kb actually should be K alpha and K beta. But the general public doesn't know that, and obviously that's what shows in the graph. Then this is a completely Polish one. And then you see energia, energy in kilo electron volts, and intensity in arbitrary units. And I'm going to discuss this in detail. The dimensions here are placed in square brackets. So let's just keep this in mind and move on. Let's talk about a quarter. And quarter is like 1 zloty, basically, more or less. It means that it's 1 quarter is a quarter, but somehow that's the physical meaning of a quarter. And we'll talk about what is this Q and what this physically means, because it's monetized in different countries. In Russia and in China, people want to publish the papers in the top journals. And here in Poland, you have the point system, which is essentially boils down to this. But here's some screenshot from some department of technology of modern system, complex system. And they say, and they explicitly tell you how to determine this Q factor. And I want to bring to your attention that this is actually the average percentile per article. There's a journal called Methods X, which has an impact factor of 3.7 in 2018. And in your system, it's assigned 70 points. And it has certain types of research fields that people should publish. But they say, since this is relevant for any field doing experimental work, Methods X welcomes submission from all research areas. How did this all start? I don't know, but back in 1996, Google PageRank was the algorithm to rank home pages of people. I mean, think about that. I don't know if back in the day, if you had your own homepage, people started to have homepages with the development of the internet, and they decided to apply this to journals and bin all the journals into 4 different categories, including the countries, which is interesting to look at. So this is the data from 2023. 2024 data hasn't been compiled. So just for 1 year, you can see that China published more papers than the United States, and Poland is number 20 in the year 2023, and it's number 17 in all of the data collected from 96 to 23. If you plot this data for all of these years, then the United States would be the first. So there is some value in looking at the data in this way. But the question is it really reliable? Because certain countries, they really want you to publish the paper in Q1 journals. And so there are questions about the applicability and reliability of this kind of binning. And personally, I would not bet my money on Q, but the Russians and the Chinese do. So let's just keep that in mind for now. Let's talk about the impact factor. I would tell you that it has no physical meaning. It's the average temperature of a patient in Szpital Jana Pawła II в Krakowie. It's 36.6 degrees. Somebody is dead and somebody is running a fever. But what I'm also going to show you is that the ranking of the Chinese Academy of Sciences from 1 to 3 or 4 is not quite correct. And then it goes down to the points. As I said, the philosophical magazine only has 70 points, so you would never consider publishing. I have an example where some renowned people, which I was a co-author of the paper, tried to submit it to Materials and Design, which has 140 points. Then they tried to publish in Journal of Materials Research, which is worth 100 points. And then in the Philosophical Magazine finally was published. So what really matters is not the averaging of the temperature of the patient in the Spital, but what matters is how many times your paper was cited, your specific paper was cited. And the bottom line is that when you write a paper and when you submit the paper, the most important thing is that the paper fits the journal description exactly. It's like a hand and a glove. And if there is no fit, then you're going to get a feedback, and you can see the paper was submitted to Acta Materialia and eventually was published in the International Journal of Fatigue. But here's the explanation why they didn't want to even send this paper for review in Acta. What's the criticism of the H index? Well, for one, it can be manipulated, and we know how it is done. Whenever you see the paper that's sent to you for review, you ask the reviewers to include somebody else's work, and maybe that's the work of your advisor or somebody else. So there is a way to manipulate and get a lot of citations for your specific papers. But in the end of the day, the total number of citations, including self-citations, I'm claiming is the measurement of the productivity of a researcher. So it's not more accurate, to be exact, because it's some sort of averaging. It means how many times your paper was cited on average, and the more papers you publish in a specific year brings your value down for the H index. It's a very famous painting from Tretyakovskaya Galleria that shows that this guy unfortunately got a 2 again. And the reference points are such that in Polish and Russian school grades, you have 1, 2, 3, and 4, and 5, but only 2 and 5 are used. And in the United States, it's A, B, C, D, and F, and somehow E is missed. Or if you go to the first floor of this building, it's actually not the first floor, but the 0th floor in Poland and in Germany. So I asked this question, why Chinese Academy of Sciences only uses 3 rating instead of 4, from my former student who is now a professor and director of the Materials Testing Center, and he says it's cultural. So there's a lot of cultural things that we will discuss today with you that are going to be interesting related to the publication of the papers. These are Chinese Academy of Science ratings for mechanical engineering, and you can see that some journals are Q4. And again, just because of the name of Philosophical Magazine, they don't know that Griffith in the 1920s published his first work on brittle fracture in that journal. And if you do research on fracture, that's where you would want to submit your paper. There's obviously Google Scholar, and you can look at the specific data. Bill Nix is a retired professor at Stanford. You can see his papers that and the number of the citations. It also calculates the H index, and also does this for the last 5 years. But what I'm saying is this is the productivity number. So his research was cited 72,000 times. Another example is John Hutchinson from Harvard. His research was cited 113,000 times, and I'm happy to have a paper back in 1999 with John Hutchinson from Harvard. So how do you look at the data? This is me, if you pull it up, and the number of the citations, this is basically my PhD thesis, and this is also another project that was done at the University of South Florida. This is another project done with Chinese, and another one which I've done at Motorola. So you can see if your paper is cited many times, it must have some certain meaning and becomes super popular for whatever reason. But that's how the raw data looks like, where you have the number of publications versus the number of year versus the number of citations on the right y-axis. And here I tried to get quite a bit of funding and didn't publish any papers, but after that, on average, was publishing over 10 papers per year. It's not like anybody really cares about it, but in my department, professors are expected to publish 2 papers per year, and there's no metrics that's being applied to the productivity as far as the Q factors or points or H index. Now there's software that can actually bin all of your publications and what areas you have done most of the contributions. So material science, multidisciplinary, there's some from applied physics, there's also from condensed matter physics and so on. But nowadays, you can just look at your data, or more importantly, other people that evaluate, you can look at this data to see where the contribution was done the most. Well, this is how we learn. We learn by copying, and I was not born, when I was born and you were born, we were not able to speak. So somehow we acquired the language over the time. But the bottom line, if you copy, here's the original. If the original has a flaw and you copy it 1,000 times, it doesn't make it any better. This is why sometimes you see 100% with a space, or you see 700 degrees without a space, or you see 200 MPa without a space and the lower P, or intensity in square brackets A dot U dot, which actually stands for atomic units, as I will discuss later. So relearning is much harder than learning correctly in the first place, and this is part of the problem. And if you are training your children in English, they'll probably speak better English than you would, because they start speaking English and learning English from a very young age. Also, another important thing is that you should have an ORCID so that everybody knows who you are. Also, I suggest that you create a profile in Google Scholar and ResearchGate Academia so everybody knows who you are. Not a problem here, but in China and Russia is the use of the official email address. Many authors use their private email address at 163.com and whatnot, and part of it is that the university in China and in Russia does not always provide the official address. Again, here it's not a problem. And maybe you want to use an expert to make the corrections of your paper, but not just English, but somebody who would know that MPA should be spelled like this and not like that, and who could correct your 700 degree C that's spelled without a degree. I give you a word of caution, because sometimes you get emails like this that appear they come from Springer, but if you read this email, it says Spring Editing Firm, and the email address is Gmail. So for $20, they will correct your 1,000 words. So my message to you is, if you want to hire an expert, hire a real expert that knows something about the field, not just the English or something like this. Another common problem are the references. And you can see here it says Cow et al. Most of the journals require all of the authors to be listed. And sometimes I've seen some journals require only 6 authors or only 3 authors. I want to come back to this. And again, in Poland, it's not a problem, because it's very easy to differentiate between the first and the last name. In Chinese language, the last name comes first and the first name comes last. Also, there's no convention to write from left to right. They can write from right to left, top down, bottom up. It doesn't matter. No spaces, no punctuation. If the referees see that somebody's first name or the last name starts with a lower character, it means that this paper comes from Chinese, and that discredits the validity. It's also important to properly place the references in the text. Somehow, even for renowned scientists, it's a problem to format the references. Now, luckily enough, we have ChatGPT. So what you can do is you can format the first reference and upload the whole list to ChatGPT and say, please format the references using the same format, and it will do it for you. Otherwise, it becomes a daunting job. Let's say you submitted your paper to PhysRevB, and then it got rejected. Then you submit this paper to Applied Physics A, and the format for the references is different. So you have to sit there for the whole day, reformat the reference. It's a big waste of the time, very common to make a mistake. Okay, square brackets. This is the figure from one of my papers that I published with TU Dresden. They didn't even bother to translate from German to English. So we have Zeit in minutes and Temperatur in degrees C. For now, what I want to say is, please leave the square brackets for something like this, the notations that are mathematical notations. And also, my message to you is that when you write 100 nanometers in your paper, you're not putting nanometers in square brackets. So I do have 2 backup slides, because I researched this topic quite a bit. There's no single reference, the origin, which will tell you to put the units in square brackets in the plots. Also, let's take a look at this table where H is in gigapascal. It's the hardness. E is the elastic modulus. It's divided by gigapascals. But then I'm plotting a quantity which is hardness squared divided by the elastic modulus to the third power. So automatically, you see, I cannot use a slash. And this is the formatted table. And it looks much more consistent where you just put whatever it is, hardness, comma, space, and the units. And we will talk about the zeros as well, but here you can see 36.0 plus or minus whatever. There's actually ISO 80,000 standard. So please refer to that document to see what's the proper use of the square brackets. Default software setting, everybody's using Origin, and I don't know who purchased it, but you have a site license for Origin. Origin is called Origin because they put all the zeros at the origin they can, like this. And if you can tell me the reason why there are extra zeros over here, I'll be happy to hear it. But I have 1 zloty in my pocket, and if I just add 2 zeros, it becomes 100. I would love to see that. But this is one of the first graphs I made for my paper, and you can see that there's some ticks on the top axis, and there's some grids. The default settings are not something that you want to use, so you want to customize your graphs. Okay, you tell me which one you like better. Do you like the legends boxed, or do you like the legends non-boxed? Which one looks better to you? Without the box. Okay. Also, I tried to find this in Google, but in Russian culture, and apparently in Polish culture, if they put a person's name in a box, that means that they're dead. I was not able to find it in Google, but here it is. Also, please pay attention when this graph is going to be printed in black and white. You will not be able to differentiate between the data. And also, AU means atomic units, as I will tell you as well. Not a problem in Poland because Poland is a civilized country. You don't steal the software, unlike Russia and China. But there's a lot of software that is stolen. And I personally use Kaleidograph. If you were to pay for Origin without the university discount, you would pay $13 per month or $900 to buy a certain version. And I was forced to use Origin here, so there's no other way. There's no way you're going to use Kaleidograph or learn how to use any other piece of software. So it's okay. I'm learning a lot as well, which is a part of my development. But please realize that the figures are going to be printed in black and white. So red color is going to be black and white. What you should do is you should either use a laser black and white printer to print, or you can use the software to remove the color to see what it would look like. Also, it is strongly recommended to use vector graphics. And you can see here the pixelation. The reason there is pixelation is because there is raster graphics. I learned it the hard way when my paper was rejected 3 times by Thin Solid Films. But what you can do easily is you can install in Windows a PostScript driver, printer driver, and then you print to file. And then you will create a file with the extension PRN. And after that, you can easily change the extension to EPS, which stands for Encapsulated PostScript. It's actually a text file with instructions to the printer. But you can submit this file directly to the journal, and they will do a good job and make sure that it's printed in vector graphics rather than raster graphics. You can see here, EDS analysis did not lose. And there you don't see any pixelation here, but you do see it here. Okay, again, I said 1 zloty is 1.0 zloty, 1.000 zloty is still 1 zloty. What you see here is log of, I don't even know how to pronounce it properly in English, but this function, sin h, and that's where I would use the square brackets. Also, you see that -1 or 1.0 should be just 0. And sometimes I hear that this means precision. I don't know what kind of precision you want to show on a graph. If you can explain this to me, I'll be delighted to discuss this with you about the 0. So what's wrong with this graph, for example? First one is you have true stress that's divided by megapascals, and megapascals are misspelled. P should be capital. You can see Origin automatically puts 0.0 because the next one is 0.1. I called Origin in 2010, and I told them about it. Finally, they implemented this 10 years later in the version 2020. Version 2019 does not have this option. And also you can see that there's no data differentiation when it's printed in black and white. So there are ways to improve this plot. How do you get rid of zero in Origin? This is how. In versions starting from 2020, there's an option that says 0 is 0 and no trailing 0. There's also a variable TLC, which will also by default will get rid of this extra zeros. You can see this is the interface from version 2019, and it doesn't have this option. The latest interesting interaction with Origin is when I saw this plot, and it says here 10 times 10 to the negative 4. And technically there's nothing wrong with that, but 10 times 10 to the negative 4 is 10 to the negative 3. And this was doing it by default. So first they asked me about the license. I gave them a Jagiellonian University license. They said, it's not your license. I said, I'm a visiting professor here. Please help me. Please treat it as a temporary license, because they sent me to this Polish company that sold the Origin. And in the end of the day, they fixed this problem by creating their own text column and just plotting the text column. So I say this is a bug in Origin that needs to be fixed. Let's see how many years it will take Origin to fix this bug. Also, not your problem, but in Chinese Windows, there's a special character for degrees. And it's very visible. You can recognize it. Also, there must be a space between degrees and centigrade, but not space between 10 and degrees in this case, as we will discuss, and I'll actually show you the standard. What's wrong with this plot? The resolution is poor. You can see pixelation. Again, it would not be a problem if you used raster, if you used vector graphics. The label does not start with a capital letter. There is no space between intensity and arbitrary units. And AU actually stands for atomic units, and you can look it up. So using AU for arbitrary units is wrong. And the reason I know is because one of the reviewers told me that some time ago, and so I use it correctly. But I think there's no reason why you shouldn't be using arbitrary units instead of A.U, which stands for atomic units. Which one do you like better, the one on the left or the one on the right? It's a matter of personal preference, right? But if you look on the one on the right, you can see it's pixelated. Recently, I've heard that the first thing that people look when they review papers is affiliation. Well, maybe that's the first thing, but then they're going to look at the figures, so they're going to look at the abstract, and they're going to look at the conclusions. And maybe then after that, they will read your paper. This is how Facebook started, by comparing pictures of two people, the one on the left and the one on the right. Is it okay to put makeup? If I came here wearing makeup, maybe not a good thing, but if I was a female, maybe that's okay. But which one do you like, the one on the left or the one on the right? You can see there's no space in the micron bar on the right, but in fact, this is the same exact person. The one on the right is the same person wearing makeup, and the one on the left is not. So the idea is to make your paper look a little better by putting makeup. But for Dziewczynka, doesn't matter. So here's the makeup and the dress, and here's no makeup and no Photoshop. So in the end of the day, if you have a result that is worthy of publication in Nature, it doesn't matter if there's makeup or no makeup, because diamond is still a diamond. You can see here, this is diamond, and this is also diamond, and this is diamond that has been cut. So in the end of the day, the research is jak mleczko in the refrigerator. It has to be fresh, otherwise when you put it in coffee, it turns into cheese, and you can make nalesniki serum from that. But only very rarely you can publish research that is outdated. And if you just copy the results from an American paper, it's a setup for failure, because you have your own diamonds, and you have the equipment at Jagiellonian University to make your own research and all the facilities to do that. So there's no problem with this. And we're going to try this Facebook startup idea and compare the figures, the one on the left and the one on the right. Which one you like better? Again, the answer would be that it's not quite the same kind of figure. You're comparing apples and oranges, but here, if you look at the heat flow, which is divided by milliwatts, this maximum value of 1043.01 degrees, I would question the ability to measure at over 1,000 degrees to hundreds of a degree. Also here, temperature is divided by the degrees. The ticks here can be easily removed, so the figure would look a little better. And then we have the weight loss that's divided by the percent. So if you write 1/2, that means divide by, and it's very common that this kind of notation is used in many graphs. So my message to you is to polish your paper, meaning un-Chinese it, and please type it in font 12. And the reason is because many of the reviewers are old, they have bad vision, and they print it on the physical paper, and it's hard for them to read. Also, use the same font in the figures. Don't use the special characters. AU means atomic units, arbitrary units means arbitrary units. So I've been doing this for over 30 years, and hopefully I can try to communicate to you that there is a way to improve by using the vector graphics, for example, and making sure that your graphs first would occupy less physical space in megabytes, and you would not lose the resolution. Another example of this pixelation that you can see. This is a true type font. Blow it up 500%. There's no lost quality. And an easy way from any software, I don't care, is to have a driver for the PostScript printer, and then you print to the file and you rename PRN file to EPS. Let's have a comparison. Which graph you like better, the one on the left or the one on the right? The one on the right. And somehow, and I don't know how, but the ticks on the inside look better. Here you can see A dot U dot and also dimensions in square brackets and no spaces in front of the degree C. And which one do you like better, the one on the left or the one on the right? Left. Okay, because you're used to origin, and that's okay. I fixed everything, but let me ask you another question. Do you like this labels, numerical value, left justified or right justified? Which ones look better? You can see here 0 is right next to the axis and 0 here is the offset. But you must like one better than the other. That's how our human mind works. Anyway, also punctuation can be a problem. Punctuation is kind of interesting because if you have French windows, it automatically would put a space in front of the semicolon. And this is the train station in Moscow called Stanция Библиотека имени Ленина, Vladimir Ilyich Lenin. And no, they use no spaces. I don't know who did this, but this is right there. This is the right spelling. So there has to be a space after the punctuation point, not in front of it. This would be the way to write it. And in certain cultures, maybe in certain languages, the punctuation can be funky. Like in also, if we go back here, you see maybe not on this graph, but there were commas instead of the periods over here. So in Polish, you separate the decimal point with the comma and not a period. If you want to go to the source, which I strongly recommend you do, there's DIN 461, a German document from 1973. And I was amazed by the quality of the graphs that they made in 1973. God bless them. If you look at ISO 80,000-1 from 2022, this is the standard. I only got the previous version. They want money, and maybe I will request one from my library. But there it explicitly says a Celsius temperature from -7 pробел, space degree C to plus 5 degree C. This is a message from Marta specifically because she keeps arguing with me about this space with the degrees. Okay, let's talk about equations. Which one do you like, the one on the left or the one on the right? Let's start with this.
Both are not correct. Compact.
The one on the right, because the brackets are spanning through the whole thing. And the other thing that happens in China quite a lot is they use, instead of using Microsoft Equation Editor, they use MathType. And MathType is $64 for a year. Again, please don't steal the software, which is not a problem in Poland, but in China, it is a problem. One word can kill your paper. Implant versus implantant. Transmission versus transmittance. Induction versus inductance versus inductor. Capacity, capacitance, capacitor. These are different words, and the units must be correct. Also, you need to make sure that you're using the right significant figures. So 1050 degrees C versus 1047.01 degrees C. 150 megapascals versus 147.678 megapascals. Also, quite often people use the words firstly and secondly, and technically there's nothing wrong, but it's a Chinese cousin in their first and last name. Firstly and the secondly. And please do not invent the words. Z61 alloy is positiver than that of, but negativer. And I haven't seen this in Polish, but I've seen it in other papers. And that's what happens when you try to literally translate certain words from your native language to another language, English. The other thing I've seen is, what are you pointing to? And in certain cultures, it's the other way around. So just like you would point to that. So whenever you use arrows, you would point to what you're pointing. But this is what happens sometimes. Again, looking at this example, when it's printed in black and white, you will not be able to, I literally printed it and took a picture of it. You will not be able to differentiate, but there's a way to put the symbols like this, and then you only put those symbols on certain data points, and that's the way for you to differentiate between the data, even when it is printed in black and white, like it will be in the journal. Lin Mei Chao is a graduate student that I worked with when I was on sabbatical in China last time. And she got an award from the Chinese government. Mei Chao, so in Chinese, United States is Mei Guo, and Mei Chao is American money, so her nickname was $1. But we published 2 papers, and this was regarding pitting corrosion in duplex stainless steel. So she performed SKPFM. You can see that along the grain boundaries, there's higher current. And in 3 years of experiments, this was the only image I was able to find that was publishable. My message to you, please make beautiful figures, because that's the first thing that reviewers are going to look at. And sometimes there's no way to avoid the color, like this, for example. And this is one of the raw diamonds. So you ask your boss to pay for color prints, and it roughly costs $1,000 per page. But it may be worth it, because there's no way to represent something like this without the use of a color. So it's okay to spend some money if you have it in the budget. If you don't have it in the budget, it's okay to find $1,000 to print something its color that's very beautiful. So if you want to publish papers in Acta Materialia, you need to read papers in Acta Materialia. My advisor, Bill Gerbrick, was subscribed to this journal personally, and he had all of the journals from the beginning on the shelf in his office. You want to publish in Nature, read more papers in Nature. You should also read at least 1 paper per day, and that's what I used to do just to keep up. Also, it helps to read the review papers, because in 1 paper you can get a lot of information. Also, you can review other people's papers. That's how you learn. Copyright I will skip, because this is the topic that requires a separate seminar. I don't know if you know what plagiarism is or what is self-plagiarism. But whenever you write the experiment description, there's a tendency to just copy from your previous paper, and then technically it is self-plagiarism. So write the description from scratch of your experiment, even though it may be the same. Attend conferences. And I used to attend the Materials Research Society conference. This is the one that's coming up in Boston in November, and they still have the call for papers, so you can submit your papers. There's nothing wrong with publishing at MRS. I published 33 papers with MRS. The reason is because I didn't want to wait for 2 years to see my paper published in a journal. It's also good for students, and the turnaround time is 6 months. So I'm sure there's a AIP meeting, and there's a specific physics meetings, and you probably organize a specific meeting in Zakopane. So it's a very good way to present your ideas to other people to look at. Polish your paper. In here we use this kind of toilet, and this is the Chinese toilet, and we use the regular utensils versus chopsticks. And you can see that there is no trap for some of the Chinese plumbing, which has been a big puzzle for me. So I published these papers in some kind of journals. I found also this problem in Poland in case somebody removes this trap. I don't know why somebody would do it, but I've seen people do it. And then you have the sewer lines exposed. Use ChatGPT. The best thing is to format the references. It works perfect. And also you can say, please, ChatGPT, please write a paper in Nature about titanium oxide photocatalysis, and then the next day you submit and it's accepted. That would be the great idea, but you know, you can check English, which is very good. And I know that you can publish papers in Nature because the sky is no limit, really. But there's no ChatGPT in China. If you try to go to the website, it doesn't give you that. I didn't realize that there's no Yahoo in China since whatever, the 2021, so I couldn't read my email. There's only Baidu. There's no Google Maps, or Google Voice, so if you have an Android phone, forget about it. It's not going to work with all the services that are used to if you go to China. Only Baidu. But the problem with Baidu is that they trained their AI models based on Chinglish texts, so it's no good. They can say whatever they want, but only WeChat that they have. So these are the most useful papers that I published, and they're published in Predator journals because I didn't worry about this, because sewer gas leakage is a crisis in China and nobody pays attention to it. And other papers related to health that I thought that I have academic freedom to publish, to share with people, and this has been very useful so far. These are some examples of my best figures. And here you can see it took a while to produce a plot like this. Here's another one. If I were to improve anything, I will make the ticks a little bit shorter. And then this is another one where there was some photography involved, and you know, you need to put something that you can put a reference. So this is the best I could do so far. And you can see if you like it. If you like it any better. See, I couldn't use a slash here because it's E, comma, space, volts over the millimeter. So volts divided by the millimeter. This is a meaning for the slash. Okay, in conclusion, I suggest that there is a way to unlearn and learn again how to do it better, and to polish your paper. And to do that, you need to read other people's papers and have your own idea and conduct your own research, because you have the world-class equipment and world-class facilities at Jagiellonian University that other places simply don't have. And believe me, I have been to and done research in different countries. Again, in the China, in Russia, they should not be stealing the software. And the sky is no limit. So if you want to publish, I can help you. Thank you so much. Okay. Now